Greetings, my name is Robbie and I am the project lead of the Duke Bolt team, and we are here to explain the work we have completed towards the senior design project. One of our main deliverables of the 2 semesters was to automate the plotting of the load profiles via a Python script. Our team was also tasked with analyzing those plots generated to compare the hard AMI, aka Advanced Metering Infrastructure data, with the models given to us on Duke Energy software. Upon completion, the team began creating another Python script that automates the voltage profile plotting and calculations. This was a more intensive script due to the larger amounts of variables that go into the voltage along a chosen line. Without further ado, here is Michael Nguyen to talk about the load profile script.
Hello everyone, this is Michael here, and I'm here to tell you about AMI and load profile. So what is AMI stands for, you ask? So AMI stands for Advanced Metering Infrastructure. So AMI is a way for a power supplier to take data remotely from the engineering office. This is then measured and stored in a database where engineers can analyze the frequency in order to determine the amount of power to supply at a given day. So load profiles are graphs that represent energy usage over a 24-hour period. They are broken into time intervals, and they are broken into 15 minutes, 30 minutes, or 1 hour increments. So as you can see here, here's an example of a residential load profile.
That's a mighty fine looking load profile, Michael. The load profiles show a customer's power usage for a given day, allowing for a power provider, such as Duke Energy, to determine the proper amount of power to supply. Accurate representations of customer usage can help Duke Energy save and make money, as power is not overproduced nor underproduced, keeping the customers happy. The handy-dandy AMI data Michael mentioned has allowed us to update the load profiles for customers in a primary circuit, also known as a distribution circuit, that is connected to a substation carrying the power demanded to Duke Energy customers. The data was collected for the months of January and February of 2019, allowing us to update the customers' load profiles to model their usage for winter weekdays and weekends. Again, this representation of usage will keep the customers happy.
In the voltage profile graph shown, the x-axis represents distance from the source and the y-axis represents the voltage value. As the distance increases, the voltage drops. This drop usually occurs due to internal resistances along the line. And now, let's get into the technical aspects of voltage profiles.
Thanks, Ami. To generate these load profiles, there were 3 main challenges that needed to be overcome. Firstly, the circuit that models the portion of the grid that we were analyzing was not composed of simple one-way paths that can easily be plotted. Rather, the topology was a bit more complicated. Secondly, the raw data that is used to represent the circuit looked like this. And there are thousands of values. So we had to come up with a way to format this information in order to analyze and use it. Lastly, the voltage values and the distance values for the voltage profiles had to be mapped to their respective locations on the circuit. The programs that were written in order to solve these problems can be grouped into 3 main categories. Shown here, these programs were written in Python because it was simple to use, fast to debug, and had many useful packages. Once the load profiles could be generated, they were checked against the distribution management software that is used to simulate the circuit. Who would have thought that electrical infrastructure was so complicated?
I hope this video gives you, the viewer, an insight on what the Duke Bolt team has come together and worked on throughout the past 2 semesters. We were very excited to work alongside a company such as Duke Energy, as well as our academic mentors. The team and I would like to thank all of the academic mentors and industry supporters for all the support given to us over these past 2 semesters. We would like to offer a special thanks to Brent and Shelby for speaking with the team one-on-one and guiding us through any questions we had.